Today is May 13th, 2022. We're gonna talk again with my grandpa. Okay, so I wanted to kind of go back to our conversation two interviews ago, and we had left off. You told me we talked for a while all about Rocketdyne, which I found to be really interesting. But eventually, you left Rocketdyne, and that's kind of, we talked about Rocketdyne, but then you left, and I don't know why you left or what happened and where you went after that. So I was hoping we could pick up from basically why
we can pick up from there why I left Rocketdyne.
Or I don't know if restructuring or whatever what was the.
Okay. I went. I don't know what we've talked about Rocketdyne, but I went to work for them in the fall of 1955 and worked for them for 11 years until 1966. I'm not sure when and what time of the year I left them. I went to work at Rocketdyne again, like I said, in the fall of 1954. They hired me because of my previous aerospace experience and knowledge. I was hired at the top of a classification that had A, B, and C in it, I think. And there was one more classification above that called tech, which was the highest hourly employee they had. In hiring people for the work that was going on up there, there was nobody they could hire that already had that experience, because the experience just didn't exist. All our, let's just say, rocket engine experience came when all the German scientists who were involved in the V2 or V3 rockets chose to come to the United States rather than go to Russia. And it was a learning experience for me too, to go from the lightweight structures of aircraft and designated aircraft power plants to a rocket engine component test area. I could probably talk all day about what the facility was and what I did, but it would probably be mostly meaningless. And just to say that it involved hooking up instrumentation lines, both electrical and pneumatic, installing components in a small test cell to simulate what they actually did on the rocket engine, and everything associated with it. So having said that, it would be much easier for me to answer questions than to aimlessly ramble on like I'm doing right now.
No, that's fine. You give a different perspective. We talked about it 2 weeks ago. You gave me a good idea of what you did there. But I'm curious about why you, what was the trigger to move on from Rocketdyne? So I know you were involved with
Well,
some of the
why
Apollo
did I,
stuff.
okay,
Yeah,
why did I leave
yeah.
Lockheed
I know you were doing
Aircraft
involved with
Service?
Apollo stuff, related
Okay,
stuff in the, I think it
okay.
was the J2. But like eventually you moved on, and I'm
I,
curious to where you moved on to. So why you left and where you went.
okay. I was working at Lockheed Aircraft Service. The reason I moved on, and I don't know
No,
whether
no, 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 no. Why you left Rocketdyne, not why you got to Rocketdyne.
why I left Rocketdyne. Okay, uh, I was working in the highest classification uh, they had there, as far as hourly paid uh, employees were. It was in the sometime, let's call it mid-year 1966. Uh, our work was finished. But the work we did had involved components for the Apollo 5 booster and for the second and third stage engines. Our work was finished, and they started cutting back. They we lost about. I had decent seniority. We were not protected by your union, and the only protection the union could have given us would be to lay off people by seniority. First in, last out. It was a first in, last out union situation, but not being represented by unions. It was whoever they felt like laying off, they did. And they were going to cut me back and cut me back on wages. And I knew this was coming, so I started sniffing around for another job. And trying to remember, was I laid off? I went to work for a company on Van Owen Street in North Hollywood called Scientific Engineering and Manufacturing Company. And their primary business was to make what's called a thermocouple. And these were industrial temperature sensing devices which could gave the temperature of materials like iron, steel, gold, platinum, you name it, at high temperatures. Gold melts in the low 2000 degree area, as does steel. Aluminum melts at roughly half that temperature, roughly 1100 degrees Fahrenheit. All all substances have three states of existence. One is gaseous, another is liquid, and the third is solid. A gas like oxygen, we know it is a gas and it keeps us alive, but it can be turned into a liquid if you get it cold enough. And from a liquid, it actually turns into a solid substance, again, if you can get it cold enough. So all substances have the same properties. The only difference is the properties change from gas to liquid to solid at different temperatures. So steel is solid, but you get it hot enough, it melts. And if you continue to get it hot enough, not steel, that would be iron. Steel is a component of iron. Iron, as we know it, is a solid at what we consider normal temperatures. And if you can get it hot enough, it turns from a liquid to a gas. Okay.
So you went and so after
So
Rocketdyne,
I went to work for scientific engineering and manufacturing company at a higher wage than they wanted to cut me to at Rocketdyne. It was actually considerably higher. So I took a layoff. They wanted to cut my wages. They wanted to keep me. They wanted to keep me, but that was they probably couldn't afford me. And I went to work for Semco, and I worked for them until the fall, for roughly 4 years, until the fall of 1970. Okay.
what type of stuff did you do for that company?
Okay. They were primarily a company manufacturing thermocouples, as they're called, to measure substances from ambient means current, what we experience, to very high temperatures, as high as close to 3,000 degrees. Different thermocouples for different temperatures had different, were made of different materials. I'm not going to get into that, but they were manufactured using specific components. Once they were manufactured, we had to calibrate them. Now, we used the freezing point of water as a basis for calibration, and and the calibration had to be very close. The freezing point of water is 0 degrees centigrade, or 32 degrees Fahrenheit. I'm not going to go into the story of the different ways of measuring between these two measuring devices, but they both measure the same thing with a different component. Now, in measuring, and what we would do, we would take an ice pat, a cup full of ice, and how would I explain this? When something is in the process of either freezing or melting, no matter what it is, when it's in a stage of flux, which means nothing is happening, so to speak. If you were to run trying to think of a word you would understand. You take a piece of ice and it starts melting. As the temperature goes up, it starts melting. But when it's in the process of going from a solid to a liquid, it stays at 32 degrees.
Correct.
It stays in 32 degrees until it's all melted. Just let me
It's
say
latent
that.
heat.
So
Are
on
you
a
looking for
chart,
latent heat?
okay, on a chart, if you see it on the graph, it would come down when it started melting. They got to 32 degrees, then it would go horizontal until it was melted. Then when it was all melted, then it would continue on down. Okay.
Sorry, are you
So-
looking for the word
So
latent heat?
when any
Grandpa.
materials in the change of going from a solid to a liquid or a liquid to a solid or anything like that, its temperature stays the same while it's doing what it's doing. Okay.
It's caused by the late.
Okay. So now we had to calibrate a thermocouple. Now, when you join two dissimilar materials together, no matter what it is, it sets up a millivolt EMF, electromagnetic force, which is a slight current that can be measured in the 100ths or the 1000ths of a degree. See how I can explain this. But in order to be as accurate as possible, take water, for instance. Water has minerals in it. The water we drink has all kinds of minerals in it, and maybe other stuff. And what this does, it affects the temperature at which water changes from a liquid to a solid, or a solid to a liquid, a water to ice, or ice to water. If there's contaminants in it, it's not 32 degrees exactly. It might be 32 degrees point 01. It could be something other than 32 degrees Fahrenheit or 0 degrees centigrade. So what we had to do, we had to make our own ice, and we would use what you call water that's
Distilled?
okay. That's the word I couldn't hear. We would use what was called distilled deionized water. What a it's distilled deionized water, which literally had no impurities in it. Then you make fill a little container with this ice and put the tip of the thermocouple in it. And as soon as it started melting, the temperature of the ice would stay constant until it was all melted. We put the ice in it, and at 32 degrees, it develops a specific EMF, electromagnetic force. It would be in the hundreds or the thousandths of a degree. And we would have calibrated instruments, and while it was in that state, we would read the EMF, as it was called, and we would put the voltage generated at 0 degrees, so that the people that used the thermocouples, when they put it in a substance that was the same temperature as melting ice, they knew that it was 0 degrees. So it could do it forward or backward. And by making thermocouples up with different materials. Most of them thermocouples had the two materials. I can't think of the names of the metals we used right now, but they were exotic materials, and that's how we calibrated our thermocouples. And different, like I said, different materials would require different thermocouples. If you're measuring the melting point of aluminum, it was made one form of material, and if you went up to gold or iron, we actually used gold as a, because what you can do the same thing with gold or iron or any other material. You heat it up until it melts and start letting it cool off. And as soon as it started changing back to a solid, there was a specific temperature.
Oh, very cool.
Exactly. Okay. It's your mother. It's your mother.
Okay, we're back after.
We're back. Where was I?
You basically explained that using different metals, you could get precise temperatures because of the latent heat. That is
so if they wanted to calibrate something from the freezing point of water up to something that's 3,000 degrees by using different metals, they can make a chart, make a graph of it.
That's very cool.
Yeah.
So you were involved with the process of calibrating these thermocouples as they were being manufactured, and then you were kind of in validation.
Okay.
Is that correct?
This was a new science for me, and I had to learn a lot. And we had a contract with I'm not sure who was responsible, but at this time the nuclear plant at down by Oceanside, just off the 101 freeway. You if you've been to San Diego, you've seen it. You know which one it was.
San Onofre.
San Onofre. Okay, there was another nuclear plant up the coast near San
Luis Obispo.
Strano. Okay.
Yeah, that's
okay. In any event, what they had to do is they were pouring concrete for the reactor building. They had to embed in the concrete thermocouples, so they would know what the temperature of the concrete mass that was going to surround the nuclear pile would generate the heat for the to make the steam to run the generators, so to speak. And there was a specific process for making the thermocouple for this process, because once they were set in the building, there was no way to access them if they failed. So they had specific instructions for how to make these thermocouples. And one of the now when you braze something or solder, brazing or soldering means connecting two substances to either similar or dissimilar substances with a second or third dissimilar substance. Example, connect a copper wire to a copper terminal in a switch, such as the wiring in a house. Two ways to do this would be the bare copper conductors with a rotary connector that would screw on to the uninsulated parts of two wires or three wires, or depend on the bid. What we had to do now is when we had these making the thermocouples and we're raising the point where the two wires were connected, we had to do it without a flux. Flux keeps out oxygen when you solder something, and so you can make a connection. There's two types of fluxes when you solder sheet metal together, galvanized sheet metal together, as you would in a air conditioning. Can't think of the name. Something that conducts hot air from an air conditioner to a register. What do we call that now?
I can't think of it either. So
Yeah, it's a round sheet metal tube, an insulated sheet. Okay, and anyway, you can use a soldering paste put right on it. You can't do that with an electrical conductor because the paste would be an acid of some kind, and that while it would work on the moment, it would probably create an acid that would destroy the connector after a year, 2 years, or whatever. So you had to use a solder for electrical things that had the acid, had the I can't think of the word again, built under it. So there are different types of solders for soldering. And what we had to do is we had a little chamber with a window in it and had little gloves in it. And it was fed by an oxygen-free atmosphere. I forget what the gas was we used to replace oxygen, but we would put the items, to set up the items to be soldered in this little box with a window in it and get it all ready to solder. And then we had to use a special torch because you're trying to you can't burn a regular torch in a atmosphere that has no oxygen for the flame to burn. So we had to use a special torch that provided its own oxygen. And we had to solder the connections together for these thermocouples. I remember it was a real touchy thing. Not all of them were good. So once we made them, we had to run them through a very stringent test to make sure they were good. Anyway, that's some of the work I did for Scientific Engineering and Manufacturing Company. Semco, it was called.
That's very interesting, actually. I'm glad we got into some of that because it's and it sounds familiar that you had these.
I still remember. I can't remember the names of a lot of the components we used, but I remember how we did it.
And it sounds familiar to the problems you had at Rocketdyne. You seem to have to work with these non-atmospheric, basically work in no atmosphere problems. So
Well,
you,
yeah, you're talking about the J2
yeah,
hydrogen.
which we talked about.
Yeah,
Where was this company Semco located in the
in North
valley?
Hollywood on Van Owen Street.
Okay, I was just curious.
Yeah, yeah.
So then in the fall 1970, you said you moved on from this company, correct?
Okay. I was working, like I said, I was working there. Now, do you know who Bernie Stickold is?
We talked about Bernie.
Bernie and Rhoda. I
Yes, we
think
talked about them. Yeah, we talked a little
we
bit about them.
I think we've already talked about them.
Yep.
Okay, Bernie worked for a scrap company called Alpert and Alpert. The main office of Alpert and Alpert was on Soto Street, just south of where I can't. Soto Street around. You can look at the map. Go north on Soto Street, past First Street, and there is a major. At one time, the West Coast office of Sears Roebuck had an office on the corner of Soto and this street I'm thinking of. I
Give me
think
a
the
second.
building is still there.
Okay. I don't know where First Street is actually.
First Street,
In the valley?
Soto is, I think, a north-south street, and this street I'm talking about is an east-west street. It would be north of First Street.
First Street's in the. Are you talking about like Silmar area? San Fernando?
Okay, that's unimportant. Hey, Alpert had a scrapyard there. But they had a second scrapyard in Carson on off the 5 freeway in Carson. I don't remember the street. Bernie worked there, and what happened is their Ferris buyer left. I don't know whether he died or he quit or they fired him. They needed somebody fast, and so Bernie thought of me and asked me if I wanted to go to work for them. And now I at scientific engineering and manufacturing. We finished the job for the nuclear plant at Onofre, and we prior to that we had a lot of work, but I could see the work was drying up, and what was happening is the same thing that dried up Rocketdyne when all their development was finished. The same thing was happening at Semco. I could see it coming. So this job was offered, I think, out on Wednesdays. I kept my mouth shut going to work until Friday, and then I just told them I was quitting. I had a better job, and they weren't happy about it because it left them in a bind. But I had to think of myself before I could think of them. So that's what happened. And I went to work at the scrapyard. It was a simple sort of work. The work I did was a truck would come in with scrap, pull on the scale. I'd go up and look at the load, see what it was, and put a value on it. And the value was rated at a certain amount of money per ton. What they would do is pull on a scale, I would weigh them, then the truck would continue in the yard. Was a ferrous load. It would just be dumped. Ferrous means it could be handled by it would be iron, and it could be handled by an electromagnet crane. If it was non-ferrous, then it could come in anyway. It could come in loose material. As an example, if you take some sheet aluminum and it goes through a stamping machine, and after the object that they needed was stamped out of this continuous sheet, then what was left was like a skeleton of what it originally was. And this could happen with aluminum, sheet, brass. There were all kinds of exotic metals that received. They would go to a different place on the yard. I would just weigh it in. I wouldn't weigh the individual material. Then if it was a non-ferrous material, it would go over to the what we call the dock, where they workers on the dock would unload it. They would test the material to see specifically what it was, and they would individually, if it came in bales, they would weigh the bales. If it was in a drum, they would weigh the drum, dump the material out and weigh the drum again and subtract the tear from the gross. And that's in general how they did it. I put a price on ferrous materials only. And I also had to learn the tricks of the trade when they tried to, they would bring in a load of cheap material like old refrigerators, dishwashers, washers, components made of steel, sheets, galvanized sheet steel, painted sheet steel. They would have electric motors in them, and then wash racks. They would try to hide what that was to get a higher price for higher grades of steel. And it was a learning process for me, and I'm not going to go into it what I had to go through to learn, but I caught on fast what their tricks were. And when you would see a pickup truck come in, and I'd see its gross weight of 12,000 pounds, and they're where I knew the weight should be somewhere in the 6,000 to 8,000 pound area. You know there was some slag, some heavy slag underneath the load that I saw, and so that's how I learned. And I worked for them until 1986, and on my 63rd birthday, August the 16th, 1986, I retired. And now that I look back, I realize I've spent over 1/3 of my life retired. Haven't had a W-2 form. You know what a W-2 is?
Yes, I do. I'm
Yeah,
currently working, so I do have to.
Everybody that has earned income gets a W-2. Well, instead of W-2s now, I get 1099s, and they come in bunches.
So let's see. So this is, I did find it. I was looking up Alpert and not Alpert with the P. So
Yeah.
it is but here's down on Soto Street, or
Where is
Soto
it?
Street here. Soto Street, right?
Soto Street,
I was also looking up DeSoto.
1820. Oh, okay. I'm 1820 South. Okay, Washington Boulevard. How's that
Yeah, there's
sound?
Washington. There's the LA River, and it's at both of these.
Okay, all right.
Yeah, this is
1820 South Soto. That does it.
yeah. I was looking in the valley. I was looking at DeSoto at first too, because
Okay.
that's the Soto, the place that I'm more familiar with.
All right.
So you ended up working at.
I worked at a yard they had in Carson. Now,
Oh, you
what
didn't work.
hap-
Did you?
okay,
You
what
didn't work at
happened to
this location?
No, I didn't work at that location. I worked at Carson in the Long Beach area.
Oh,
Okay,
so you had a long drive then. That was a
okay,
long commute down there, right?
okay. The yard they had in Carson where I used to work was closed down for environmental reasons years
Okay.
ago. Yeah. So I can't speak much for now, but
Got
it's
it.
gone.
That makes sense.
Yeah, it's gone.
Let me get rid of the share screen.
Okay,
So then you had a long commute there, I assume. I mean, that's a long ways from the valley.
Okay.
Correct?
Okay. Where do we go to now?
Well, I want to ask you a little bit about, since we're doing your jobs in later life. There was also, I know that because you talked about it previously, during this period, you had also were working at Pep Boys for at least for a part of it.
Oh,
So I'm
okay.
curious about the period that you were working at Pep Boys.
Okay.
Because I know that was, and
Okay.
if there's any other jobs that you had at
Okay.
the time.
What happened working at the scrapyard, and I went to work for Alpert and Alpert roughly 1970 or 1971. I made a good wage there. So between 1970 and 1976, I'm trying to orient myself. There's something missing there that I.
Was it earlier than that?
No, I left Alpert and Alpert. I went to work for them in 1970 or 71, and I left them in 1986. In 1986, on the my 63rd birthday is when I retired. I retired from Alpert, and I no, one of the reasons working for Alpert, they had a profit sharing deal with their employees. And I can't quite remember how it worked, but in any event, in 1986, I got my retirement thing was about $96,000, a considerable sum back in those years. And after I retired, that's 1976. To check I retired in 1986. because
86.
Esther passed away in 1980. Okay, now I got myself straightened out. Esther passed away
Okay,
in
so I want to
January.
back up into. So I wanted to back up just to try to fill in the gaps because I know you for a period, and I think it might have started. I don't know if it started when you were at Rocketdyne or if it started when you were at the thermocoupler place. But I was just curious about when you were working the second job at Pep Boys because you had alluded to in a previous video that
Okay,
you were
and
making a bit of money at Rocketdyne and then
okay,
you took a second job at some
okay.
point.
I went to work at Pep Boys. Actually, that was Friday nights, all day Saturday, and Monday nights. Why did I go to work part time?
And when was it? Like, and
Huh?
how long were you there for? And I'm
I
just curious, like when you did it, why and when you did it, and like for how long you were there.
I it's a little hazy to me.
Okay.
Do 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 do, and then let's see. It's just not clear to me why I went to work for Pep Boys. I I know es, Esther went back to work too for her. That's a another story that I'm not sure fits in here. Esther
Okay.
working for some friends.
Well,
Okay,
let's get that to the next. We'll do that next video
yeah,
because I want to. I want to talk about
yeah,
Esther actually next
it's
video.
5 minutes to 10. I'm a little confused now about the way things went along then. So you
That's fine.
you want to wrap this up?
Let's do that, and we'll come back to it. And yeah, let's. I think this is a perfect time to end for the day.